The world's largest single-dish radio telescope, located in southwest China, has detected a new repeating fast radio burst, or FRB. Radio bursts can flash and fade in a matter of milliseconds and are therefore very difficult to catch.
The vast and infinite expanse of space has always been a source of mystery and fascination for us humans. We have always wondered what secrets lie beyond the reaches of our own planet, and whether we are truly alone in the universe. And now scientists have discovered something truly remarkable: a single massive source in space that is sending us thousands of messages. But what could it be? Is it a natural phenomenon, or could it be something more? The sheer scale and consistency of the messages is unprecedented, and scientists are left with more questions than answers. Could this be a sign of intelligent life beyond our planet? And if so, what are they trying to tell us? These questions have left the scientific community buzzing with excitement as they explore the possibilities and try to unravel the mystery of these messages from space. So come and join us in today's video as we delve into the details of how scientists recently identified an enormous object in space that continuously transmits thousands of messages. Are you familiar with fast radio burst, FRB? While it may seem like an unremarkable phenomenon to some, it has captivated astronomers, scientists, and space enthusiasts alike. Part of its appeal lies in its enigmatic nature, as we still have much to learn about it. Imagine the excitement when scientists began to pick up multiple FRB signals within a short period of time, and the signals just kept coming. Space is home to many mysteries, and FRB is one of the most puzzling. It makes us wonder who or what is trying to get our attention, and what could they possibly want from us. But what is FRB exactly? FRBs are brief but intense bursts of radio emission that last for mere milliseconds. They possess the characteristic dispersion sweep of radio pulsars. The first instance of FRB was discovered by Dr. Duncan Lorimer in 2007, but upon scrutinizing archive data, scientists found that FRBs were detected around 6 years earlier in a pulsar survey of the Magellanic Clouds. It's no surprise that FRB is also referred to as the Lorimer burst. When telescopes capture an FRB, researchers pay close attention to a feature called dispersion, which measures how spread out an FRB is by the time it reaches Earth. In the vast expanse of space, the space between stars and galaxies is not empty but rather filled with plasma, a soup of charged particles. As light travels through space, it encounters various obstacles that can affect its journey. One of these obstacles is plasma. This plasma can cause light, including radio waves, to slow down. Interestingly, lower frequency radio waves are more strongly affected and slowed down more than higher frequency waves. Fast radio bursts consist of a series of frequencies, with the higher frequencies arriving on Earth before the lower frequencies, causing the dispersion effect. Scientists use this dispersion to estimate the distance of the FRB source from Earth. The more dispersion, the more plasma the signals has passed through, suggesting the source is farther away. The first FRB that was detected looked like giant pulses from radio pulsars and was traced to the location near the small Magellanic Cloud. However, due to limited instrumentation, the flux of the signal could not be measured exactly. Researchers believe that the first FRB could occur in several hundred bursts every day, but with a small probability of detection. After the first FRB was discovered, scientists thought it was a unique phenomenon because it only occurred in 3 of the 13 beams of the park's multi-beam receiver. However, a few years later, a student named Sarah Burke-Spoler discovered another burst that had almost the exact dispersion as the Lorimer burst, which led to a renewed interest in the field. In 2013, Thornton & Co. detected 4 more Lorimer bursts, which were officially named Fast Radio Bursts, FRBs. These bursts had significantly higher dispersion measures than the original Lorimer burst and were found through the high time resolution universe surveys at the park's 64-meter radio telescope. The brightest burst showed scatter broadening with power law dependencies, similar to what we would expect from extraterrestrial sources of radio emission. In 2014, the first FRB discovered in another observatory was announced, but its source remained controversial, and scientists are still trying to figure it out. It's a baffling mystery that researchers are excited to solve, and with advancements in technology and research methods, we might get closer to understanding these mysterious bursts and their origins. Now hold on to your hats, folks, because the plot is about to thicken. In 2019, scientists dug deep into their data and made a discovery that would leave even the most seasoned astronomers' jaw on the floor. The analysis revealed that over the course of just 47 days, the FRB 121102 source produced a whopping 1,652 flares, breaking the record for the most flares ever discovered from an FRB. This new information opened up an entirely new world of possibilities for researchers to explore as they scrambled to find any sort of regularity or periodicity in the bursts. Unfortunately, their efforts were in vain, as they couldn't find any signs of a pattern. This lack of periodicity was a real head-scratcher for the scientists, as it made it incredibly difficult to pinpoint the source of the bursts. They were left wondering if these flares could be produced by more than one mechanism, and acknowledged that it might be quite some time before we truly understand the mysteries of FRBs. To make matters worse, most FRB sources flare just once and then disappear, making it even more challenging for scientists to predict or trace them. A select few of the FRBs have been known to give off signals repeatedly, and one of the most active ones is FRB 121102. This oddball has allowed scientists to track it all the way to a dwarf galaxy 3 billion light-years away. But it's not your typical FRB. It's super busy and follows a unique pattern. It goes through 90 days of activity and then 67 days of silence. The amount of activity from FRB 121102 has given astronomers an opportunity to observe it when it's emitting, and one of the tools that has helped with this is the 500-meter Aperture Spherical Radio Telescope, or FAST for short. Even during the telescope's testing phase, it picked up FRBs. In just 2 months, FAST collected a massive 59.5 hours of data in a 47-day period. The peak rate was 122 bursts in just 1 hour, which is the highest level of activity ever seen in an FRB source. Thanks to this massive data haul, the researchers were able to analyze the source's activity statistically. They separated the bursts into 2 categories, those with higher energy and those with lower energy, which had distinct differences in properties. The weaker bursts were shown to be more unpredictable in nature. Despite the lack of regularity in most FRBs, scientists are still determined to track them down. Through their investigations, they have discovered that these bursts originate from galaxies that are millions or even billions of light-years away, yet produce enough energy in a mere fraction of a second to power hundreds of millions of suns. Recently, the scientists have stumbled upon another intriguing FRB, FRB 190520, detected by the FAST telescope in China. This FRB stands out because it repeats itself more frequently than others, releasing 75 bursts in just 6 months. Curious to learn more? The team used the powerful Very Large Array radio telescope located in New Mexico to focus on the FRB. Finally, they were able to locate the source of this mysterious signal, coming from a dwarf galaxy located about 3 billion light-years away from us. The research team made a surprising discovery when they found a faint radio signal originating from the same spot as FRB 190520. This persistent signal is a rare find, with only one other FRB source known to have it. Using the location of the dwarf galaxy that FRB 190520 came from, the researchers were able to determine the distance from Earth. However, their results revealed an odd discrepancy. The estimated distance based on the FRB's dispersion was 30 billion light-years, which is 10 times greater than the actual distance of 3 billion light-years. While this is both remarkable and perplexing, it's worth noting that only 19 of the over 800 FRBs discovered have been traced back to their origins, allowing for accurate distance estimates. For the rest of the sources, astronomers must rely on dispersion to gauge their distance from Earth. The scientific community has been captivated by this new FRB, which poses even more questions than answers. Unlike the 19 other FRBs whose distances were estimated with similar accuracy to their actual locations, the dispersion method used on this one was way off the mark. Scientists are perplexed and can't help but wonder, are persistent radio signals becoming more frequent, and what generates them? Is the same mechanism that causes FRBs also responsible for the persistent radio signal? Furthermore, the team was surprised by the unusually high dispersion rate of FRB 190520. Was it caused by something nearby, or is it related to the FRB itself? The team is determined to uncover the secrets of this strange object using multiple telescopes around the world. With more discoveries to come, we might eventually unravel the mysteries surrounding FRBs, paving the way for a better understanding of these peculiar objects in our galaxy. In conclusion, fast radio bursts are a fascinating and mysterious cosmic phenomenon that has captured the attention of astronomers and the general public alike. Despite significant progress made in recent years, including the detection of more than 800 FRBs and the tracing of some of their sources, there is still much that we do not know about these bursts of radio energy. From the discovery of persistent radio signals to the surprising dispersion estimates, the more we learn about FRBs, the more questions we have. However, with the use of advanced technology and the collaboration of scientists around the world, we can hope to uncover more about these strange objects and gain a deeper understanding of our universe. Now let's hear what you think about these strange FRBs in the comments section below.